much. Let me share the screen. You can see the screen, right? Okay. Yeah. So yeah, thank you very much for invitation and also the introduction to about me. It's quite honored to be here. So that the title is actually quite a big step, and I think we are along the way, but hopefully that it's quite a long journey, but at least we started. So let me tell you a little bit. So I'm from Renewable University. So it's actually not in Bangkok, but it's in Nakhon Ratchasima, my south 3 hours. But here we also had a synchrotron facility. So anyone that would be interested in coming, please let me know. We also, this is the work that we done that show you a little bit in the first half. It's have been with many collaboration from the synchrotron itself, from Stanford University, also Berkeley, and also St. Andrews. This is some of the picture of the group, and also from time to time we have visiting visitor from Indonesia. So for example, I think you see one here is Ishma, right, here. So from Malang, and to do the research in supercapacitor. So if you are interested, also welcome to contact. If anything we can work together, we'd be very grateful to. Okay, this is some of the picture of the synchrotron. At the left one is from the Berkeley lab and wildlife source. So the right one is in the synchrotron that we use. Part of the measurement is done from both synchrotron. So okay, so the outline of my talk would be just roughly divided into two parts, right? First part I will talk a bit about the research work that has been done as a researcher, and so this study of the behavior of electron at the oxide surface, which is a concept of this so-called negative electronic compressibility, which can be useful for energy storage, which I will mention in my talk. And the part two, this is some of the things that the work at a startup that called EQ Tech Energy, that work on the energy storage, that try to go along that journey that has the title, that try to decentralize how to use energy around places. As this is a beginning, right? So the first part will be like the part of the research work has been done. So it's a bit technical, but I will come. It won't be long, but I will stretch on the important part. So in general, actually, myself is not start as the research on energy storage at the beginning. In general, is I do study the quantum state in matters, and that's the synchrotron technique is the key, the main tool that I use to study this. For example, some data that I showed at the beginning is I've been quite a while that for the last 10 years or so, we study a lot on the electron at the oxide surfaces, and this is telling something strange. And then, which, for example, the material that we used at 10 years ago, that I do measure on the strontium titanium oxide. So this is actually is strange. The strange part is that it is an insulator, but once you shine the heavy UV light on it, or basically I use a synchrotron light that I focus on the surface. Is at the surface, it can turn into conducting surface, and you can see this is an electronic state using the angle resolved photon emission spectroscopy. It basically tell you about the Fermi surface and basically how electron can be moved or interaction at the surface. So we can, for example, we can obtain for like the charge density of the surface where this conducting electron happen at the surface. And something is also strange that normally the electron at the oxide surface usually has a strong interaction, but in this case it seems to have a very light mass or appear like the weekly interacting, but not entirely. So we also do this kind of thing. We can change the doors and see and so on. So this is been puzzle for some time, and we can understand, and that the work that 10 years ago that published in Nature Material, we try to understand why that happened, and then together with other people in other areas also study this as well. That so it turned out that this some strange thing that there's an oxide surface. There's this some strange phenomenon it called negative compressibility. It means that as the name or I put it in another way, is that negative capacitance. So if we use this layer in between capacitor, you can enhance the capacitance of this capacitor quite a lot. For example, in this is not my work, but in MIT group is also at the same year, at the same time. What they find that the enhancement of the capacitance can go up to like 40% or so with this additional layer of electron at the surface that have funny interaction at the surface. So this also we also come to the work of that. We also try on the capacitor ourselves with the light, and then try to create this like 2D electron, the conducting electron at the surface of oxide. And we can also see this is in 2013, quite a while ago as well. We can see that the capacitance of capacitor, once you have this conducting electron at the surface, the capacitance go up. For us at that time, it go up like 20% or so, and this can be used repeatedly. So you once this the with and without electron at the surface, you can have this effect of increasing or just be the same as before. So this is interesting because the even more interesting is that to enhance this, you basically use very little material to begin. Basically, it can be like if the material stay there, it can be only maybe a few layer of atomic layer. So it's used very little of material, and you can enhance like 20 to 40% at least in capacitor. This is so I put in the title is large enhancement of capacitance for price of almost nothing. It's almost nothing in terms of material. So you add little to that. But this concept we also use as a concept for other energy storage as well. But the capacitor itself is quite clear. So this now so far the story I'm telling is from the physicists as a perspective of physicists that do research on just studying quantum state in matters. But then there's a time that also this is by luck as well, that in Thailand we also has a big grant that been at that time to try to funding people to do research in energy storage. So that come to my second part, that once we had something that looked interesting, and then we can try to make use of that, and then we also do some research further in supercapacitor and also battery. But not part of that is not mentioned here because it's due to some part is confidential right now. But I can tell you quite a rough idea of what this can go into the development of startup that called EQ Energy, and then some part of this will be done right away because some part is not our technology but existing technology together with like customization that we try to study the market in Thailand. Okay, so from that I changed the field, the mode a little bit, that so try to look from the business point of view, that how can be concept of how we try to improve or what we can done differently from others, right? So this is maybe the data is a bit a while back, that the battery itself may be the represent of the lithium battery of cell phone, of mobile phone, that the cycle, as you know, that the lifetime is around for mobile phone like 4 or 5 years ago, then that maybe about 1,000 cycle, or it can last for about 3 years or so, and then you can start to see funny things about your cell phone. It cannot charge fully, for example, like that. And that's the good part about lithium battery is that the specific energy is high for at least for the cell phone or that kind. But the other is still not competitive in the sense that the lifetime is not so long. It takes a while to charge, and also the cost, the LCOE or levelized cost of energy is quite still high. That is the price per capacity and per cycle is still not so attractive. So this I use the current is in Thai baht, sorry. But it's you can use I maybe make the comparison later, but in the opposite. So the supercapacitor, the life cycle is quite long. The levelized solar energy is actually a lot lower than the battery, but the downside is that the energy density is still like 10 times lower. So this the research that I focused at the beginning try to keep the rest the same, but try to boost the energy density of these supercapacitor. So how we do it differently, that I mentioned in the first part, that we do a lot of study of quantum state in matters, and the one that I just mentioned, that negative electronic compressibility is something that may be useful. This is also a later work that in 2015 that we also worked on another material in chalcogenide, that you can also see some of these pronounced effects. So I did not mention at the beginning, but this is also maybe an analogy that can see that when we talk about negative things in physics, it usually sometimes it's counterintuitive. So the positive compressibility is like pouring water in a glass. The water level will be keep rising, and then it's gonna get filled, right? But if it's negative, it's the opposite of that. Like you put the water into the glass, and then the more you pour, the water level keep lower. And this, of course, the water is just analogy. You see that it's a magic, but if you change the water to electron and the glass to a certain material, you can see this kind of lowering in the chemical potential, and that we can do using the synchrotron to probe it directly, and we can see those effects. So with this concept, we can use again and try to apply to like supercapacitor, and we can see the enhancement of capacity quite a lot, substantial, and that's the concept that we use to try to boost the energy density, and we can boost it to about 30 not watt-hour per kilogram for the capacitor back in about 2 years ago. So that the concept that we try to maybe mass production, but and apply to the deep tech kind of startup, but it's still quite difficult in Thailand, and that's we change the direction a bit later, but the data itself is quite interesting, and quite the concept is quite attractive. Okay, so I also maybe mention a little bit in a bit more general that the motivation that come to me as well, that in Thailand or in everywhere also, that there's a talk that I got listened to, and then it's quite inspiring for me, that it mentioned in this conference that to do the leapfrog in energy, you go for solar and wind power. In Thailand, there's not so much of the wind power, but the solar power we have a lot. and then there's no grid, I mean decentralized, because the cost a lot of energy is going to the grid, how to deliver the electricity from far away to your home, and that is a lot of cost, and is also the obstacle as well, that in certain places that there is no electricity, it will be very costly to put it there, or it's never be possible, like in the mountain, in the park, and in somewhere. And also the another motivation is the solar cell is a clean energy. Okay, so this I maybe not need to mention a lot, but the solar cell is quite cheap already. The cost of the battery is still high, and that we try to see what we can do. Also the infrastructure of the EV in Thailand, also there's a big obstacle if we want to go big. For example, if in Thailand, if we have 1 million EV car at the same time, the power consumption will be maybe like 10 times of what we can produce in Thailand. This is not mean that energy is not enough, but it just means that the energy management has some problem, some limitation. So using energy storage, we can reduce it and make it a buffer, and then you can go bigger scale in current state. Okay, so from that we try to move something, do something, and that we form the startup called EQ Energy. So this is also that get a lot of motivation when I study at Stanford, and how make maybe basically the short name is similar, but Suranadi is the SUT and Stanford is SU. So we hope that maybe we can make something that useful for other people. And that come to the startup. And this some of the thing that we have the right now, the factory that try to do something and work on that. This part is actually changed a little bit along the way, or not change, but add the term that so instead of try to put so hard on the deep tech, it's really hard to get the funding from deep tech point of view. But if you use the existing technology that happen now, the study that I do on supercapacitor help a lot as well to analyze certain things that maybe because the lithium battery itself is also a variation of that available on the market. Some is used a lot, in some is not, but some is not used a lot. For example, like lithium titanate, that also has characteristic that's similar to the supercapacitor, and it can be useful in certain direction because the levelized cost of energy is a lot lower than others. And this is some comparison, and also a certain application, for example, the lead acid, which is also toxic, can be replaced, and not just because from the point of environmental friendly only, but also the cost can be reduced by a lot in certain applications. Actually, a lot of almost all of them is possible. So in this part that we do in parallel with the try to do set up a deep tech startup, we also do the study the market at the same time, and then try to make more prototype and how we go into the see the market, how we can do that, how we answer the pain point of the people in Thailand, and these are the area that we do study, like from just the solar cell together with battery with the energy storage with the solar cell, and as for the UPS is uninterrupted power supply, and also like the mini EV. We also hope to do the big EV as well, but that's too competitive for us, so we start small. And also there's some certain application in smart farming. So this is I will go quickly on this one, but if you have any question, you can also ask at the end. That so the focus that solar cell has been done a lot in Thailand already, but the one that mostly is on grid type, so no battery, but the off grid or hybrid, there's a lot of room that you can add into that. So we focus on this off grid and hybrid that together with utilize the energy storage, and we can make this kind of product that that test. Also, of course, I start with my house first. That at some certain time there's a power outage, and my house will be on still. The light in my house only the village is all dark, right? For example, and then now then more houses start to be light on when the power outage because you install a certain more. And the useful number that we also study is that sorry again I put in Thai baht, but the cost for the electricity in Thailand per kilowatt hour is about 4 baht. But if you use solar cell together with energy storage, the cost, the initial cost that you but this is not the market cost, but if you do that, is less than the one you pay from for the government already. So this is quite attractive because you can get a cheaper electricity and you can put everywhere that you want. There is no need of power line to go to the house. So also again do some testing and also spread once we have this. So this is my mini house in the farming land with no electricity around, but we put in solar cell, and then you can turn on air conditioner during the day. You can use the pump and they've been. But this is not new, the function, but the new part is that the cost is actually effectively is cheaper than available in the market if you calculate correctly. And also we also do like project of CSR, for example, in national park and certain things that far from or that had a lot of problem with electricity. We also have this kind of the office that in the national park that there's often of time there's a power outage every time you have the raining because the tree fall down to the power line, for example. So now is all back up, fully back up. It never have the power shortage anymore. Also the tourists visiting also use the clean energy that come to this. Along with this, there are also like EV bike that, for example, is the in a national park is quite far from the gas station. So effectively, you can reduce, you can have clean energy, and also economically, people save a lot of money from that. Basically, the government office save a lot of money from that. Another part that we do is the UPS, the uninterrupted power supply. We start from small, and then is also the big because the cost for most of them use the lead acid battery to back up, and that often of time it's die really quickly in 1 or 2 years. You need to pay it. It's cheap. It's inexpensive to invest at the beginning for lead acid, but you need to change every 2 years or 1 or 2 years. And that's a lot more cost than change to the lithium battery. So we also replace a lot of that to many sites, at least 2,000 sites plus already. And also in factory from small to big, like the half kilowatt is also half megawatt. Sorry, that already been done. We have some of the smart farming also been done. The farming also is also useful in terms of function, but imagine that there's many farming land that you want to do more smart farming. There is no electricity to go there. If you want to put the lights, too expensive. But if you use energy from solar cell and with the right side of the battery, you can save a lot of money from that. But this again is a challenging part because normally the farmer don't have the money to invest at the beginning because you need to make initial investment. But that's something we still need to work on. Transportation also done a lot from the small EV like the in hospital you do mini EV that change the battery from the lead acid and the golf cart. The golf cart maybe is easy to imagine if you use one. The golf cart for like 4 seat, the battery for the lead acid the weight is around 160 kilogram. But if you change to the lithium based one, that correct for the right one, then we can reduce maybe like 40 kilogram, like reduced by 100 kilogram lighter. That also the performance is also even lighter, but the performance is better. And for the motorcycle, this also I've been to Malang quite a time, see a lot of motorcycle in, and also the Gojek is perform very well in Indonesia. And this also, we also done this in Thailand for example, like the motorcycle taxi, and they can save a lot of money for those. For example, if you this is break even point is quite quick, is 2 years, and pollution free, because we have some like the dust problem PM 2.5 and Thailand. And then, for example, this also again, sorry, in Thai baht. For example, if you the taxi, the motorcycle taxi, if they pay around, if they run about 100 kilometers a day, they will pay about 4,000 baht a month for the gasoline. But if we change to electricity and with our battery, they can pay only maybe 500 baht to use by 3,500 baht a month. So mean that every 2 years they can get a free a new motorcycle every 2 years, because just reduced by change from gasoline to EV bike. These are some model that also the performance. Also we work together with the motorcycle company that not just save the money, but the performance of the bike need to be good as well. Then so now this we work out on those areas. And another part, that last one now, for the charging, this is also prototype in university, that we install the right battery and the solar cell. We can make the off-grid charging station. In that, if once you install and you calculate, already the use here is not a lot, but after you install the first time, you can get the free transportation for another 25 years. So these are the things that can be changed, and importantly, it can set up everywhere, that in the mountain, in near the remote area, in the farming. These are the things that can be changed. And so this of the journey that I made. So to summarize a little bit, I actually start as a researcher into quite fundamental study of quantum state in matters, but some part that could be useful in energy storage. So we try to work on a little bit on this aspect, that can create some prototype, and also startup that going quite well. So we still young, but so far the trend is quite good, and we can do a lot more to serve people who buy the product, save the money, and also get the performance better in certain things. So, and with this, my contact is here. And if you have any question, please let me know. Thank you.